Now my dear students, today we are start the part 2 equilibrium. In crash course, my dear students, here chemical and ion equilibrium is present and base state of matter. You know very well state of matter, one or two questions base equilibrium is coming. So my dear students, in equilibrium we can see the questions which are asked in NEET exams. In liquid gas equilibrium, the pressure of vapors above the liquid is constant at. My dear students, your answer is A, constant temperature. Liquid gas equilibrium, pressure of vapors is constant, because when you can see this liquid and this is the vapors, when temperature is constant, then vapors is constant. When temperature is increases, then vapor pressure is also increases. So in liquid gas, this is a gas, this is a liquid, equilibrium pressure of vapors of the liquid is constant, always at a constant temperature. Now my dear students, we can go to the question number 2. Here this question number 2 is as in 3, 7 and 17 year. So my dear students, it's also important question. The equilibrium constants of the following are. Here you can see the N2H2 ammonia K1, N2O2 NO, H2 plus half O2 H2 K3. Now my dear students, he give this equation, targeted equation, and find out the K. You can here see which of the equations in which reactants are present here and in which product are present here. Now we can see here water present, no problem at all, you can take here. Here NO is present, you can take here, and here you can see the ammonia is present in product side, and then this ammonia is present in reactant side. So my dear students, this reaction is reverse, and when you can reverse this equation, you can get that twice NH3, 2 gives N2 plus thrice H2. Now we can cancel with each other. This N2 is cancelled by this. This is the thrice hydrogen is present here, and here you can see the one hydrogen atom. So my dear students, it may be this is multiplied by the 3. When this is multiplied by 3, my dear students, you can cancel this thrice H2 with this reactant and product. Now my dear students, here thrice H2O cancelled, here O2 plus half O2. Here thrice O2, you can always know that half O2 means 1O, O2 means 2O, and if you get the twice O2, then my dear friends, it's a 4O, and 3 by 2 O2 means 3O. So my dear friends, here 3O, because half O2 means 1O, here 3O, here O2, 2O, 5O, and 5 by 2 O2 means 5O. So my dear friends, it's right. Ammonia is reversed, twice NH3 plus 5O2, 2 gives twice NO and thrice H2O. So my dear friends, here K1, K2 are plus. When K1 and K2 are plus, means in equilibrium condition it is a multiply, and when it is a multiply, my dear friends, K1 and K2, and reverse is the K1, so it is a divided. And when this power 3, so K3 is present in the power K3, here this is a K2 and K3 are here multiply, and power of this power 3, because this 3 is multiplied here, and you can get this reverse of K1, means multiply by 1 upon K1. So my dear friends, when you can see the equilibrium constant, in this type of equilibrium constant is obtained for this equation. So you can go to the answer A. Question number 2, answer A. Here K2 multiplied by the K3 power 3. Why this power 3? Because 3 is multiplied here. K2 and K3 are, when this V equilibrium is added, means equilibrium constant is multiplied. And this 1 upon K1, here K1, and this for 1 upon K1. So multiply by 1 upon K1, because this reactions are added, means equilibrium are multiply, and you can get the answer. In this type you can solve the questions in this trick. Now my dear students, we can go to the question number 3. If the equilibrium constant for N2 plus O2 to is twice NO is K, the equilibrium constant for half N2 plus half O2 to is NO. My dear students, it's a just reverse. When this is just reverse, to gives twice NO, N2 plus O2, it's just half of this K. Half of this K, it means it's a root. And my dear students, when you can get the root, means K dash is equal to root K, or my dear students, it is also called K power 1 by 2. So, question number 3rd, you can get answer D. Now, my dear students, we can go to the question number 4th. Given the equilibrium constant for the reaction twice SO2 plus O2 to give twice SO3 has a value of 278 at a particular temperature. What is the value of the equilibrium constant for the following reaction at the same temperature? Here you can see the value of equilibrium constant at a particular temperature. My dear students, you can see the 278 is the equilibrium constant. First of all, you can see twice SO2 means if you take the K and it is the K double dash. Why? Because you can reverse this equation and divide it. So, K double dash is equal to root 1 upon K. So, my dear students, your values are equal to root 1 upon 278. And my dear students, you can 1 upon 278 root, then you can get the equilibrium constant for this reaction. So, my dear students, your answer is question number 4th, answer is C. You can get the 6 into 10 to the power minus 2. Now, my dear students, we can go to the question number 5th. Given the reaction between two gases represented by A2 and B2 to give the compound AB, at equilibrium the concentration of A2 is this one, B2 and AB is this one. If the reaction takes place in a sealed vessel at 527 degrees Celsius, then the value of Kc will be. Here, my dear students, you can put the direct values because Kc is equal to product upon reactant. And here you can see the product AB power 2 upon active mass of A2 and active mass of B2, because my dear students, these are the reactants R and these are the product. So, you can put the values of AB because this concentration of present is at the equilibrium. So, you can directly put these values 2.8 10 to the power minus 3 power 2 upon A2 is 3 into 10 to the power minus 3, B2 is the 4.2 into 10 to the power minus 3. So, my dear students, when you put the values and divided this equation, then my dear students, you can get the answer C, that is 0.62. Now, my dear students, you can see here question number 6. For the reactions N2O2 twice NO, the equilibrium constant is K1, the equilibrium constant is K2 for this reaction. What is the K for this reaction? Here you can see the two reactions. Here the reaction 1 is N2 plus O2 to gives twice NO plus O2 to gives twice NO, and second reaction is the twice NO plus O2 to gives twice NO2. This is the K1 and K2. My dear students, this is your target reaction. Here you can see NO2 is present in a reactant side. You can see NO2 is present in a product side. So, my dear students, reverse the reaction. Here twice NO2 to gives twice NO plus O2, and it is a 1 upon K2. Equilibrium is converted to 1 upon K2. Now, we can see here you can see the NO2 is 1. So, it is just half. NO2 to gives NO plus half O2. NO plus half O2. So, my dear students, this is the root 1 upon K2. Now, we have second reaction this, and we have first reaction is N2 plus O2 2 gives twice NO. My dear students, here you can see this O2 and N2. N2 is here, O2 is also here, NO2, but you do not want this NO, and this N2 plus O2 2 gives twice NO. So, my dear students, this is the half of the reaction. So, K1 you can half this reaction, you can convert this reaction in a half. So, you can get the half N2 plus half O2, half N2 plus half O2 to gives NO, means your equilibrium constant is that is NO2, N2 plus O2, this is the root K1, but this N2 is present in the product side. So, you can reverse this reaction also, NO to gives half N2 plus half O2. Your equilibrium constant is 1 upon K1. So, my dear student, this is your first reaction. Your first reaction is NO 2 gives half N2 plus half O2, and equilibrium constant is the root 1 upon K1. Now, second reaction these are your second reaction. NO2, 2 gives NO plus half O2, and this is your second reaction of 1 upon K2. Here you can see here NO2, NO is cancelled with each other, and O2, half O2 and half O2 are added. So, you can get the NO2 2 gives half N2 plus O2. So, my dear students, this is the you get answer 1 upon K1 into 1 upon K2. Both are multiply because both are added. So, it is a multiply. So, you can get the root 1 upon K1 into K2. My dear students, you can also write here K1 K2 power this power 2, power half. So, this is the answer of this question number 6. Your answer is C. Now, my dear students, we can go to the question number 7. Here we can see the dissociation constant of for acetic acid and HCN are this one. The equilibrium constant for the equilibrium would be. My dear students, first of all, you can write the reactions for acetic acid CH3 COOH. You can get the acetate ions and H plus ions. For this HCN, my dear students, you can get the H plus ions plus Cn minus ions. Here you can get the 1.5 10 to the minus 5. Here you can get the 4.5 into 10 to the minus 10. Your targeted reaction is Cn minus plus acetic acid to give HCN and plus acetate ions. My dear students, when you can see the HCN is present in reactant, and here this HCN is present in product. You can say this is K1 and this is K2. First of all, you can correlate this reaction, and target reaction you can achieve the target reaction. So, you can reverse this. For reverse, you can get the Cn minus and H plus ions plus HCN, and this is the 1 upon K2 when reverse this reaction. Here you can get acetic acid to give acetate ions and H plus ions. Now, my dear students, when you can reverse this reaction, you can see here by the reverse of this reaction which one is we are obtained. Here we are obtained this H plus ions, Cn minus ions you can obtain here, and this HCN, yes, you can also obtain. Now, we can see the reaction number first, acetic acid, acetate ions and H plus ions. So, my dear students, when you can, these reactions are K is equal to K1, you can get this K1 and this multiply by the 1 upon K2 here. You can plus, when both reaction 1 and 2 are plus, then you can get the, this is the multiply, plus means equilibrium constant is the multiply. Then, my dear students, you can get the K. Because you can achieve this reaction, cyanide is Cn minus ion present here, and here acetic acid, HCN and acetate ions. So, my dear students, this is the K1 into 1 upon K2. K1, what is the values of K1, my dear students? It is a K1 value is the 1.5 into 10 to the power minus 5. What is the value of K2? This is the value of K2, 4.5 into 10 to the power minus 10. So, my dear students, you can, this is multiply and divide, and you can get the 3 into 10 to the power minus plus 4, because minus 10 go upper side and minus 5 go lower side. Then you can get the 3 into 10 to the power 4. So, my dear students, this is the answer. Question number 7, you get answer C, 3 into 10 to the power plus 4. Now, my dear students, we can see the question number 8. The value of equilibrium constant of the reaction Hi half H2 plus half I2 is 8. The equilibrium constant of the reaction is simple. This is when this is K1 and this is the K dash. So, when you reverse this section means K1 is square. Reverse this section 1 upon K1 square, because reverse this section and square, then you can get this section. So, my dear friends, when K double dash is obtained, when this section is reverse and square. So, my dear students, your answer is 1 upon 8 square. So, your answer is 1 upon 64. Now, we can go to the question number 9. My dear students, in question number 9 you can see here equilibrium constant K1 and K2 for the following equilibria. NO plus half O2 to gives K1 NO2 gas and twice NO2 gas K2 to gives twice NO plus O2 gas. Here you can convert this reaction into this reaction. So it is a reverse, and when you can reverse and square to get this reaction, means your K2 is equal to 1 upon K1 square. So my dear students, you can go to the A options. If this is a reverse, means 1 upon square, double means square. So you can get. Now we can go to the question number 10. Here my dear students, if K1 and K2 are the respective equilibrium constant for the two reactions. Now here this is the 1 K1 and here it is the K2. The equilibrium constant of the reaction is this one, K double dash is required. My dear students, HCO4 here, this HCO4 is present, no problem. Here HF is present in reactant, but here HF present in product. So reverse this reaction, and reverse this reaction means 1 upon K1 is there. And my dear students, when this reaction is reverse, you can get the twice HF plus HC OF4 to give HC F6 plus water. Then you can see the cancelled or not. This is your first reaction, K1 reaction, and this is your K2 reaction. Now we can get the HF in, this is reactant, HCO4 is in reactant. Here K2, this is cancelled with this, HCF6 is cancelled with this. You can get HF plus HCO4, this section you can get, and water and HCO3 means 1 upon K1. When you can reverse and both are added with each other, means 1 upon K1 multiplied by the K2, then my dear students, you can get the K double dash. So this is the answer of this question, question number 10th, K2 upon K1, that equal to K double dash. You can go to the answer D. First of all, my dear students, this is your target reaction. You can get the target reaction, and which reactions are given by you. You can achieve target reaction by reverse or double and add the reaction. When reactions are added, then equilibrium constants are the multiply the equilibrium constant. So 1 upon K1 is multiplied by the K2. Now my dear students, we can go to the question number 11. The equilibrium constant for the reaction N2 plus H2 twice NH3 is K, then the equilibrium constant of the equilibrium. My dear students, we can see here in this question, this twice NH3 is reverse, twice NH3 to give N2 plus H2. So here this K and here K dash, if you can get the K dash, that is 1 upon K. So my dear students, question number 11, you can go the answer B, because 1 upon K, then you can get this target reaction, twice NH3 to gives N2 plus H2. And this question is asked in NEET 1996 exam. Now my dear students, we can go to the question number 12. K1 and K2 are equilibrium constants for the reaction 1 and 2 respectively. Then we can see here which are the relationship are correct, K1 and K2. Here this is the K1 and this is the K2. My dear students, we can see here this is a reverse, means 1 upon K2 is equal to 1 upon K1, and half means K2 is equal to K2, here K2 is equal to root 1 upon K1, or you can, another way you can say that is a K1 is equal to 1 upon K2 square. This K1 is equal to 1 upon K2 square. So you can get the question number 12, answer is A. Now we can see question number 13. The reaction twice A plus B to give 3 plus thrice C plus D is begun with the concentration of A and B both at an initial value of 1 molar. When equilibrium is reached, the concentration of D is measured and found to be 0.25 molar. The value for the equilibrium constant for this reaction is given by the expression. Here my dear students, the value for the equilibrium constant for the reaction. This is the Kc. Kc is the concentration of C की power 3 upon D upon concentration of A की power 2 upon B. You can put the values of C here. Value of C equilibrium is reached, the concentration D is measured by found to be 0.25. If concentration of D is found to be, so my dear students, you can see here this is the 1 minus 2x, here 1 minus x, you can get 3x and here you can get x. So my dear students, if you get the 0.25 mole concentration of D, means here you can get the x is equal to 0.25. So, in this way when x is equal to 0.25, so this is 2x is equal to 1 minus 0.5, here 1 minus 0.25, here 3 into 0.25. So, my dear students, here you can see the concentration of C ki power 3 means 3 into 0.25 ki power 3. 0.25 ki power 3 means you can also see that D is the 0.25 and my dear students, A is the 1 minus 0.5 means 0.5 ka square, and here 1 minus 0.25 means 0.75. You can see the 0.5 ka square and 0.75. Question number 13, you can see the option B, 0.5 ka square here, 0.75, 0.25 multiplied 3, 0.75 ka cube into 0.25. So, my dear students, your answer is B in this way. You can calculate here. Now, my dear students, we can go to the question number 14. The dissociation equilibrium of a gas AB2 can be represented as AB twice AB2 gas to gives twice AB plus B2. Here it is the 2, 1 minus x, here this is the 2x and here this is the x, and total moles that equal to, my dear students, 2 into 1 minus x plus 2x plus x, or you can say here 2 minus 2x plus 2x plus x. So, you can cancel with each other. So, you can get the 2 plus x, total number of moles. The degree of dissociation is x and is small compared to 1. The expression relating to the degree of dissociation x with equilibrium constant Kp and total pressure P. Here, my dear friends, when you can get the Kp is equal to partial pressure of AB ki power 2 into partial pressure of B2 upon partial pressure of AB2 ki power 2. Here, my dear students, partial pressure is what is, that is the number of moles of dissociated. Here you can see the AB ki power 2 means this is 2x, here 2x upon 2 plus x into P ki power 2 into, my dear students, here x upon 2 plus x into P for B2. Here he want the derivation. You derive this equation. AB2, my dear students, what is the AB2? AB2 is the 2, 1 minus x here, these are 2 more minus x, you can put here upon 2 plus x into P ki power 2. My dear students, you can see here that is 4x cube upon 2 plus x into P upon 4 into 1 minus x ka whole square. Then, my dear students, Kp is equal to, you can get the 4 x cube into P upon 2 into 1 upon 4. So, my dear students, you can calculate this x here. X is equal to 8 Kp upon 4P ki power 1 by 3, or you can say here this is the 2 Kp upon P ki power 1 by 3. So, this 4 is divided by 2 Kp upon P 1 by 3. So, my dear students, question number 14, you can go the answer D, 2 Kp upon P power 1 by 3. My dear students, you can get this type of questions, and this question is asked in 2008 exam, my dear students, NEET, and you can get in this question 2 Kp upon P 1 by 3. This is the answer of this question. Now, we can go to the question number 15. The value of Kp1 and Kp2 for the reaction X to give Y plus Z and A to gives twice B. Here are in the ratio 9:1. If degree of dissociation of X and A be equal, then total pressure at equilibrium 1 and 2 are in the ratio. My dear students, you can also see the equation number 1 and equation number 2. Here equation number 1, you can get the 1 mole, 1, and here you can get the 1 minus alpha, alpha and alpha. Now, in this equation 1 minus alpha and you can get the 2 alpha. So, my dear students, total number of moles, that equal to 1 minus alpha plus alpha cancelled with each other, and you get the 1 plus alpha. Now, my dear students, here you can calculate the total number of moles, that equal to 1 minus alpha plus 2 alpha, these are the cancelled with each other to give 1 plus alpha. So you can calculate the total number of moles also. Now we can see the Kp1, that equal to partial pressure of Y into partial pressure of Z upon partial pressure of X. Now my dear friends, you can put the values alpha upon 1 plus alpha into P into alpha upon 1 plus alpha into P, it is a Py and Pz, and Px is the 1 minus alpha upon 1 plus alpha into P. Now my dear students, we can cancel this. You can get the alpha square into P upon 1 plus alpha into 1 minus alpha, that is the Kp1. Now we can solve the Kp2. This is the one equation, Kp1 here and here Kp2. So Kp2 is the partial pressure of B ki power 2 upon here partial pressure of A. Now my dear students, we can see here partial pressure of B ki power 2, it means B is the 2 alpha upon 1 plus alpha into P ka square, my dear students, and here you can see the PA partial pressure of A 1 minus alpha upon 1 plus alpha into P. These are cancelled, so you can get the 4 alpha square into P upon 1 plus alpha into 1 minus alpha. When both equations, my dear friends, are divided, because here this is the ratio, so you can divide these equations. These are the divided by this equation, these are the cancelled with each other, and Kp1 upon Kp2. Finally, my dear friends, you can get the P1 upon cancel off each other for P2, and Kp1 and Kp2 is the ratio is the 9:1. So my dear friends, you can see here this is the P1 is equal to 9 multiplied by the 4 P2. So you can get the P1 is equal to 36 P2. It means answer is question number 14. You can get the answer A, 36:1. 36:1. This is where get the answer. My dear students, this is you get the answer 36:1. Question number 15. Now my dear students, we can go to the question number 16 here. In this question, a 20-liter container at 400 Kelvin contains CO2 at a pressure of 0.4 atmosphere and an excess SRO. The volume of the container is now decreased by moving the movable piston fitted in the container. The maximum volume of the container when pressure of CO2 attains its maximum value will be. Here my dear friends, it is as solid means partial pressure of CO2 that equal to Kp. Here because R are solid and solid, so it is a unity, and here you can see this is a 1.6 atmosphere. Kp is equal to 1.6 atmosphere. Now my dear students, we can see here P1 is equal to P2 V2. So here initial pressure is a 0.4 and volume is the 20. Then you can get the pressure 1.6 and volume V2. V2 is equal to 0.4 into 20 upon 1.6, and my dear students, you can get the this is your answer. And what is the answer? That is 5 liter. Question number 16, answer is D. You can here get the answer 5 liter. P1 V1 is equal to P2 V2. P1 given in 0.4. This is P1 given in 20 liter. B2 it is calculated, and 1.6 is the pressure, partial pressure of CO2. Because in this equation, partial pressure is only developed by the CO2. These are the solids. So my dear friends, you can solve this question. Now we can go to the question number 17. In which of the following equilibrium Kc and Kp are not equal? My dear friends, formula is Kp बराबर Kc RT की power delta Ng. You can see delta Ng that equal to Np minus Nr. So my dear students, when this Np, Nr, number of moles of reactants and products are equal, then delta Ng is equal to 0. Here you can see product reactant equal 0, product reactant equal 0, product reactant equal 0. Here 2 product and 2 plus here 1 reactant. Solid is not your count, but 2 and 1. So, your answer is D. Question number 7, answer is D.